Welcome to McPlum, simple solutions served daily.
You begin by listing the DFA components: states Q, alphabet sigma, transition delta, start Q0, and accepting set F. Next, immediately draw or tabulate delta from Q0 so you can follow moves quickly. Once done, perform a reachability sweep from Q0 and remove unreachable states. This reduces clutter and prevents false language observations. As you trace transitions, mark which inputs lead to accepting states and which funnel into sync states so you can see candidate patterns the DFA recognizes. Now concentrate on the middle work. Enumerate simple paths from Q0 to each accepting state, and for each path note the exact input sequence. Simultaneously detect cycles reachable along those paths. Any cycle indicates repetition and becomes a clean star component in the description. Then convert each path combined with its cycles into a regular expression fragment. Make sure to use union to combine alternative fragments, and simplify by factoring common prefixes. This yields a compact description of the language. Finish by simplifying the combined rejects using common algebraic rules, or minimize the DFA to confirm you haven't lost behavior. Once done, validate the candidate language by testing representative strings, including short, boundary, and long cases that use cycles repeatedly. If a string behaves unexpectedly, make sure to recheck transition labels, overlooked epsilon equivalents, and whether you accidentally removed a reachable state. A key troubleshooting tip: when results disagree, run stepwise simulations from Q0 on the problematic string to pinpoint the exact faulty transition.
Thanks for watching. Stay juicy and subscribe.